It's just half a ruler, right?
No.
Cool.
Mr. Roger. Here. Yeah, we have to show patience. Where's our magnesium?
Is this good? That's in the dude. Okay.
Are the latches on? Are the lighters on? Yeah. See, he's looking for matches. See?
We should be scientists.
And
It's really long.
good. 4 minutes.
You should be scientists.
What are we describing the reaction?
It's hard. Hey, Gabe, I don't think that was right.
Oh, that's right. Oh snap, that's okay.
Ow!
Turn the timer. That's really weird. That's not good.
Turn it off. So that's okay.
That's cool. That's what happens. It's cool for like 4 or 5.
Okay, well, so we're going to work out some problems on our law of our definite composition. And so first, when we have our data collected, the first data that we collected was the mass of the crucible and cover. So this was our little crucible and the cover with nothing in it. And then we took the mass of the crucible, the cover, and the piece of magnesium in there. So this was before we started the reaction. Then after the reaction, we have the product. And the product in this case is magnesium oxide. And what we're trying to do is to determine the formula for magnesium oxide. And so what this looked like was a white powder. So inside the crucible, after the activity, after the reaction took place, we had a white powder. And so then the mass, with the lid on, of course. And so then the mass was 28.48, and then we heated it up again a second time to make sure that the reaction was completely finished. And our mass shouldn't have changed. It might have changed just a tiny little bit. But what we're looking for is a difference of less than 0.03. So from this data, we can calculate the mass of the magnesium that we started with. This is the little coil of magnesium, the 15 centimeter that we buffed and rolled up. So then we're looking at our data, and the coil in the crucible weighed 28.36, and the crucible alone was 28.17. So if we subtract these two numbers, then we're going to get the mass of the magnesium that we started with. Then the magnesium oxide is our product. So this is the white powder that we had at the end. So if we look back at our data, we had the crucible with the white powder, and since we want the mass of just the magnesium oxide, so just a white powder, then we have to subtract the mass of the crucible, which was 28.17. So we're at 28.48 minus 28.17, and so that is 0.31 grams. And that's the mass of the white powder. So what we have to do here is the ratio of the magnesium to the magnesium oxide. So magnesium was 0.19, and our magnesium oxide is 0.31. So we can divide them both by the smaller number so that we have a ratio that is 1 to something. So 31 over 19 is 1.63. So if we want to have this ratio as a percentage, then we're going to do just like we did in the activity and on the worksheet. We're going to take the mass of the magnesium and we're going to divide by the mass of the magnesium oxide. And so in this case, we're going to have 0.19 divided by 0.31. And we multiply this by 100 to get the percentage, and that would give us 61.3%. So what this number means to me is that 61.3% of the magnesium oxide is magnesium. So 61% of the mass of the magnesium oxide comes from the mass of magnesium. So then, using the law of definite composition, I'm going to take this percentage right here, and I'm going to compare it to a percentage of one of the three possible formulas, and then you have to write one of your own right here. So we could say, for example, we could take number 2. If I looked at this, we have Mg2O, so this is 2 Mg and 1 O, so this is 2 times 24.3, which is the mass of magnesium on the periodic table, and 1 times 16. So we've got 24.3 times 2 plus 16, and we're at 64.6. And so the magnesium is 48.6 of a grand total of 64.6. So the mass of the magnesium divided by the mass of the magnesium oxide, which is exactly what we did from our results. The mass of the magnesium divided by the mass of the magnesium oxide. And so if the percentage match, then it's the same compound. The law of definite proportion. So in this case, well, we can see that it's not going to match because, so 48.6 divided by 64.6 times 100 to get a percentage is equal to 75.2%. So then I can deduce that the magnesium oxide that I made is not Mg2O because the proportion of magnesiums don't match. So I would repeat that for the other two, and your choice, and hopefully one of your percentage is going to match, which would tell you the actual formula for the magnesium oxide that you produced. All right, thanks for watching.